Hi guys, let's talk about separable differential equations, section 9.3. If a differential equation is separable, then we can solve it. Most likely can solve it, but there's a process to solve it anyway. A differential equation is separable if it is of the form dy dx is a function of x times a function of y. So in other words, we can set the derivative equal to a product where the product is strictly a function of just one variable times a function of the other variable. Or equivalently, we can bring this f of y over to the left side by dividing both sides by f of y. Bear with me. Okay, so if we bring f of y over to this side, we get the reciprocal function 1 over f of y. So we just call it another function of y over on this side. And then what we're going to do, we then rewrite as, well, we're going to take this differential and bring it over to that side. So we're going to have a function of y times the differential dy equals a function of x times the differential dx. We have to have strictly x's and y's in products. X's on one side and a product of the function times the differential, and all x's on the right side, a function of x times the differential. So bear with me, let's take a look at our first example. Here we have dy dx equals x times e to the y. So we have a product of two functions. This would be my function of x. This would be my function of y. So I can rewrite this as, I'm going to divide both sides or multiply both sides by 1 over e to the y. dy dx is just x. And then I'm going to take this differential, multiply both sides by dx. And this becomes 1 over e to the y. dy equals x dx. Now once we have it in this form, the left side equals the right side, we can integrate both sides. 1 over e to the y dy, the antiderivative of that is equal to the antiderivative of x dx, because 1 over e to the y dy is equal to x dx. Now we just simply straightforward integrate. The antiderivative of 1 over e to the y is negative 1 over e to the y, and that equals 1/2 x squared plus c. Now just take note, well, you can check this. This is, I used u substitution here. I let u equal e to the y, right? And then 1 over u, and you integrate and you replace. We get negative 1 over e to the y. And then the antiderivative of x is 1/2 x squared. I did not include the constant over on this side because technically what I did is just absorbed it into this constant, because the left-hand side would be negative 1 over e to the y plus an arbitrary constant, and that would equal 1/2 x squared plus another arbitrary constant. So we just combine them, and we typically only write the arbitrary constant on the input variable side of the equation. Now we're going to solve this for y. So I'm going to cross multiply, and I'm going to get negative 1 over 1/2 x squared plus c equals e to the y. I had to get it out of the denominator of the fraction. Now to get it out of the numerator, I'm going to natural log both sides. So the natural log of negative 1 over 1/2 x squared plus c equals a natural log of e to the y. And then the natural log of e to the y is just y by properties of logs. Negative 1/2 x squared plus c equals y. So therefore, the solution to this differential equation is y is equal to the natural log of negative 1 all over 1/2 x squared plus c. All right, so I'm not going to do it for all of the problems, but remember this solves the differential equation dy dx is equal to x e to the y. So let's in fact see that this is a solution by checking. So if y equals the natural log of this mess, negative 1 over 1/2 x squared plus c, then dy dx, the derivative, is equal to, well, the derivative of the natural log of anything is 1 over that anything times the derivative of that anything. All right, ready? So the derivative of what's inside is going to be, let's write here what my thought process is. I'm looking at just what's inside. It's negative 1/2 x squared plus c to the negative 1 power, and I'm going to use the chain rule. So I'm going to bring the negative 1 out front, drop the power by 1. So it's going to be negative 1/2 x squared plus c to the negative 2 times the derivative of what's inside, which is just going to be negative x. All right, I know this looks horrible, but let's clean this all up. Dividing by a fraction, this is just going to be negative 1/2 x squared plus c. Dividing by a fraction is the same as multiplying by its reciprocal. Right, this is going to be times negative x all over negative 1/2 x squared plus c squared. Right, now notice these two negatives will cancel out. So this negative and this negative cancels out, and then I have one of these up here, and I have two of them on the bottom, so this just becomes x over negative 1/2 x squared plus c, which is equal to x times 1 over negative 1/2. Oh, don't. Fuck.